Good morning, guys. Welcome to our first session for electro-pneumatics. So, electro-pneumatics, it's when we combine, it's sort of like a combination of electricity and pneumatics. So initially we used pneumatics, right? In pneumatics, we were controlling basically pneumatic circuits using fluids or air in particular, right? So now we are now combining it with electricity in such an extent that now we are using electrical signals to control pneumatic circuits in a manner of speaking. So now, instead of, for example, our 5-2-way being pneumatically actuated or being actuated by air, now our 5-2-way, for example, is gonna be actuated as a response to an electric signal, right? So okay, I know for a fact that all of you guys have been to the lab and you have seen different components, right? So as you can see, this image here, it looks like a 5-2-way. It is a 5-2-way, right? But the 5-2-way they're used to, on this side, it usually has another inlet for air, right, where it's pneumatically actuated. But this particular type of 5-2-way, it has this thing which is called a solenoid, right? So a solenoid is the one that it contains, or you can input electric signals that can be used to control your 5-2-way, right? Now instead of having an inlet here, you're gonna have a solenoid valve where you can plug in, or where you can use it to supply electric signals for in and out, so that it can be used now to actuate your circuit. Instead of it being actuated by air, it's gonna now be actuated in response to this electric signal, right? So this is a solenoid, right? So electro-pneumatic circuits, they use what you call a solenoid, right? So we'll be dealing with it a lot, like as we are going through our electro-pneumatics exercise. So without delay, right, I want us to start going on our first exercise, right? So as I just previously said, this is quite similar to pneumatics, but now the difference that now we are introducing electricity in the system, right? So we are using electricity to actuate the pneumatic circuit, right? So now how we do that here, I want us to go over to FLUIDSIM, right? So if you still remember, in pneumatics we've been using mechanically operated push buttons and pneumatically operated push buttons, right? In electro-pneumatics, we only deal with solenoid operated push buttons, right? So for example, let me just make a comparison, right? So now here in pneumatics, for example, we used to have a manually operated 3-2-way valve, right? That's normally closed. And then when we are dealing with electro-pneumatics, right, we also have a 3-2-way push button, but now instead of it being manually operated, it's electrically operated in a sense, which means now on the side here, for it to be actuated, you have to connect it has to connect to an electrical signal, right? So now, like, things are quite similar, but as I'm saying, I'm gonna keep on emphasizing this. The only difference now is that we are using electricity to control our circuit, right? So now going back to our exercise 1, right? So here in exercise 1, the process is inspecting beverage crates, right? So now they are saying beverage crates are checked for completeness with the help of an inspection unit, right? And then they are saying incomplete crates are pushed off the roller conveyor by a push button, right? And they're saying develop a control system in which this can be executed, right? So that's our description of the process. No, that's our description of the problem, right? So what I also want us to understand or catch is similarly to pneumatics, right? What I want you to focus on here, the most important aspect here is the description of the problem, it's the description of the process and the general conditions or parameters, right? And then moving on to the description of the process, they are saying beverage crates are inspected at a manual workstation. After pressing a push button, incompletely filled beverage crates are pushed off the conveyor belt by a piston rod of a single acting cylinder, right? So first keyword, right? So now we would already know that we are using a single acting cylinder, right? And they're saying when the push button is released, the piston rod is retracted to the rear end position. So now, if you look at this, right, they are saying after pressing a push button, right, after pressing a push button, the incompletely filled beverage crates are pushed off the conveyor belt by the aid of piston rod, which basically means that like when the operator let's stick with the operator. When the operator presses the push button, the cylinder advances to push out the beverage crates that are the incompletely filled beverage crates of the conveyor belt, right? And then as soon as when the operator releases the push button, the piston rod, it retracts on its own to the rear end position, right? And then since now we'll look at our general conditions, they're saying you should use a single acting cylinder, right? And they're also saying the cylinder should be controlled by means of a push button, right? And then they're saying in the event of a power failure, the cylinder's piston rod should be retracted to the rear end position, right? So now, first one, since they told us that we are using a single acting cylinder, we're going to get a single acting cylinder, right? And then, so now if you are controlling a pneumatic circuit, you always need to have your air service unit. You always need to have your compressor to supply the air, and then you need to have your air service unit so it can filter out the air or clean the air, right? And then, as I said before, since here, right, they already told us that they're using a single acting cylinder, right? And since, as I said, that now, when we are dealing with pneumatics, we are dealing with solenoid operated valves, right? So with solenoid operated, so now, if you still remember, like we have different kinds of solenoid valves, right? We have a 3-2-way solenoid valve that's normally open, normally closed. We have a 5-2-way solenoid operated, right? But they only define the fact that the other one they only differ from pneumatics in the sense that like the solenoid operated valves, they are used to control electronic signals, right? And then the mechanical operated one and mechanical operated one, they are used to control pneumatic circuits, right? So now, since they said here we're using a single acting cylinder, you should be aware that every time you use a single acting cylinder, you should have a 3-2-way, right? So now we're gonna get our 3-2-way, right? But then again, we have two different kinds of 3-2-ways. We have a 3-2-way solenoid operated, normally open 3-2-way valve, right? And we have a normally open solenoid 3-2-way operated valve, right? But here, so this one is the normally closed one, right? And this one is normally open. So now, here, going back to our statement again, they said after pressing a push button, that is when the single acting cylinder advances, which means the single acting cylinder begins in the retracted end position, right? So if we use this 3-2-way valve, right, it's gonna allow air straight into the cylinder before us having to actuate the cylinder, right? So now we are going to use this one to ensure that the cylinder remains in the retracted end position at the beginning of the process. So now I'm just gonna remove this, and then I connect this here, and then now I connect this to my cylinder, right? And then now I deal with the electrical aspect of my of my of my system, right? So as you can see here, as I said, there's no push button, right? It's just where you put your electrical wires, right? So now we need to put in our push button that you wanna press, right? So our push button, it's electric, right? So first we need to get a power source, right? And then after getting, so now we connect our, so now you need to rotate this by 180 and then connect straight, right? And then now you need to get your ground or your 0 volt, right? And also take this and rotate it 180, right? And then connect it, and then make sure you place it carefully, right? So now they said, right? So here they said, like, after we need to press the push button, right? And then that's when the cylinder advances. And then when we release the push button, the cylinder retracts, right? So the electric push buttons here, they are here, right? So we have different kinds of push buttons that will go throughout the course of this exercise, right? But now, this is the push button, right? So now what we do, right, is that we take our push button. So this push button is the kind of push button that when you press, it closes, but as soon as you let go of it, it opens, right? So after completing the exercise, I'll take you through how the other push buttons work, right? So now, to make sure that our circuit communicates to our so electric circuit communicates to our pneumatic circuit, right? We need now to get a solenoid, right? A solenoid valve, right? As I showed you, that like these cylinders, they are connected to a solenoid valve, right? So this is what a solenoid valve looks like, right? And then you connect it to the push button, and then you connect it straight to the ground, all right? And then to ensure now that they communicate, right, we label this, maybe let's say Q0, right? And then Q0, right? So now this indicates that this solenoid, it's here, right? It's located here, as I showed you, like when I was starting on the image, that the solenoid is usually located like at the front of this 32-way valve or whatever valve, right? And then now this indicates, so now sort of like this, it indicates an electrical connection, right? So here we're just trying to indicate that there's an electrical connection between them, right? And then now also want us to label this as our push button, so we can say PB, right? And then now if we simulate this, right, now you can see when we press, the cylinder advances, and then when we let go of it, the cylinder retracts. So now what is going to happen if you didn't indicate that there's a or that there's like this solenoid valve that's here, it's this one. If you didn't label, for example, let's say, let me remove this, right? So now you can see that the electric current is going to your solenoid, right? But it's not coming here because this solenoid valve is not defined, right? So even if this one receives signal, right, it doesn't know that you are sending it to this one. So you need to make sure that you always label your solenoid valves, right? So this is going to be Q0, right? And then now your circuit works. So now we have fulfilled the parameters of the exercise, right? So this is what they are looking for. So now before we move on to exercise number 2, I want us to go over the different kinds of push buttons, right? Here, or yeah. So now stop our simulation, and then let's say I delete this. So now we have what we call a detent switch, right? So this is a detent switch. So now you'll observe how a detent switch works, right? So now how it works is that when you press it, right, you only press it once. then it stays on, or it closes the circuit up until you have to pull it back again, right? So this one, so the difference between this push button, this one that we're just using now, and a day 10 switch is that a day 10 switch, it can latch, right? It can maintain the signal, right? When you press it, it just closes. Like it doesn't need you to press and hold and not. So it maintains the signal. So you can say it has a latching mechanism, right? And then this one, when you press it, you have to press and hold it, right? And then we have this other push button, right? So this one, it's always on, right? So it's always on, so it means it's always allowing, you can consider it as normally closed, right? So now when you, at the point where you need to cut the supply going to the piston, right, that's when you press it, but then it doesn't stay, when you want the cylinder to stay in the return position, you have to press and hold it, right? As soon as you let it go, the cylinder will return back to its original, or like the front end position, right? And then now, our last push button that I'd like you to go, for us to go through, right? It's this one, right? So this one, it's also normally closed, right? So it allows current to pass through, but when you press it, it cuts the current and then stays open, unlike this one that I just showed you now, which you have to press and hold the push button to cut the current. This one you don't have to press and hold. This one has you can also say it has a latching mechanism, right? You only press once, then it cuts the current, right? And then, yeah, those are the different kinds of push buttons that we'll be going over, alongside maybe changeover switches. So we'll also be using a changeover a lot, right? Anyways, moving on to exercise number 2, right? Exercise number 2. Okay, so before I move on to exercise number 2, so this is the solution for exercise number 1, right? So I will be, like, throughout, like me going over the exercises, like I'll be going over some terms that I want you to understand, right? So make sure you note them down, right? So the first one, right, like that's relevant to this exercise, right? It's direct actuation, right? So if you still remember from pneumatics, right, direct actuation was when the cylinder was directly connected to the push button, right? So that the push button could directly actuate the cylinder without having an intermediary component like a 5-way valve, right, to pneumatically operate the cylinder, or pneumatically actuate the cylinder, right? So that was sort of like that's direct actuation in pneumatics. But in electropneumatics, direct actuation, right, it's when we directly connect the push button into the solenoid valve, right? So now we are sort of like using the electric signal, right, to directly actuate the cylinder, right? So now, yeah, so direct actuation in the context of electropneumatics, it's sort of like we are saying when we press the push button, right, the current directly flows to the solenoid valve, right, to actuate the cylinder, right? But you'll see, like, as we go through exercises, you'll see how indirect actuation works. So please make sure you note down direct actuation. It's very important, right? And then let me see what time do I want you to note. Yeah, for now it's just direct actuation, right? So make sure you understand direct actuation. And then one other thing, right, for you that I want you to understand is knowing how to describe or how to explain the controller sequence or the control system sequence, right? So the control system sequence basically talks about like how the circuit is and how it works when you activate certain things. So now, let's say if I were to describe the control system sequence of this system, right? So I can say initially the cylinder will be in the rear end position, and yeah, the cylinder is in the rear end position, right? And then I can say maybe if, like, let's say I've labeled this like push button 1, right? Then now I can say when push button 1 is activated, right, an electrical signal is sent to the solenoid valve, right? And then after, when the solenoid valve receives the electrical signal, right, compressed air flows from the compressor into the 3-way solenoid operated valve. And then when the solenoid receives signal, the 3-way valve is actuated to allow air into the piston rod, right? And then after that, you can say as soon or after you let go of the push button 1, right, the electrical current is cut from the solenoid valve, right? Therefore resulting in the cylinder snapping back to its original position. So the reason why it snaps back, it's because this 3-way valve, right, it's spring loaded, right? So when it actuates to that side, it's sort of like compressing the spring, and then when you let go of the push button, it's gonna automatically snap back, right? So that's how you describe the controller system sequence, right? So anyway, moving on to exercise number 2, right? So exercise number 2, let me see. So they are saying numerous pipes have to be opened and closed in a water treatment system with the help of shut-off devices, right? And they are saying an actuation option for the shut-off valve will be sought out by means of a test setup. So that's the description of the problem, right? And then they are saying when the gate is opened when a push button is pressed, right? And then they are saying when the push button is released, the gate is closed once again, right? So now, and then they are saying a double acting cylinder will be used, and then they're saying the cylinder will be controlled by means of a push button, right? And then they're saying in the event of a power failure, the cylinder should retract back to its original position, right? So now they're saying if you go back to the description of the process, they're saying when the gate is open when a push button is pressed, right? Which means the cylinder advances, right, when you press the push button, right? And then they're saying when the push button is released, the gate is closed again, which means the cylinder retracts, right? So now, since they already told us here as well that we'll be using a double acting cylinder, right? So coming back here, right, so we're gonna remove this, right, and like this, right? So now, since we already said we are using a double acting cylinder, right, you can't, as like you remember from pneumatics, right, we can't control a double acting cylinder using a 3-way. So every time we need a double acting cylinder, we always need a 5-way, right? So now going back here, right, so now as you see, like they are saying like when the gate is open when the push button is pressed, right? Which means And then the second statement saying when the push button is released, the gate is closed once again, right? So now, which means like now, the type of push button that we are using, right, or the type of 5-way that we'll be using, right, it doesn't have a latching mechanism, right, which means it has a spring that's gonna snap it back when we let go of the push button. So now we have this 5-way, right, and then we also have this 5-way, right? So now this 5-way, this one, it's sort of like, I can say it's a bistable solenoid operated 5-way. A bistable operated 5-way, it can be electrically actuated on two sides, right? And then, so which means if you want it to advance and retract, it's only actuated by the means of two signals, right? And it has a latching mechanism, right? And then if you look at our statement, they said, like when you let go of the push button, the gate closes on its own, right? You need to press a secondary push button, right? And then, so now this solenoid valve, right? It's only actuated on one side, then it has a spring on the other side, right? Which is gonna cause it to snap back, and then with also the push button. So now when I can say when electrical signal is cut from when you let go of the push button, right? This spring is gonna cause the solenoid valve to snap back to the stand position on its own, right? And then this one, since it has a latching mechanism, it can't do that. So which means now this is the 5-way solenoid valve we'll use, right? And then we connect it to our double acting cylinder, right? And then we connect it to our compressor and our service unit, right? And then similar thing, right? So now, as I said, here, this is the solenoid part of your 5-way valve, right? So now, for them to communicate, right, you'll also label this Q0, right? And then now, when you simulate this, the cylinder advances, and then, so now we press it, it advances, and then when you let go of it, it goes back on its own, right? So that's how you operate a system using a double acting cylinder, right? So now this side, I didn't change it because they said still we're using the push button. If you look at the type of push button, it's a type of push button where you have to press and hold it. You don't have to let go of it. Once you let go of it, it cuts the supply to going to the cylinder, right? And then now moving on to exercise number 3, right? So in exercise number 3, the description of the problem is saying, let me check. Exercise number 3. So in exercise number 3, right, one term, like if you still remember, I said there are terms that I want you to be familiar with, right? So here, what I want you to be familiar with is to understand a functioning of a relay, right? So now you need to understand how a relay works, and you also need to understand indirect actuation, right? You need to also understand indirect, so you can note that down. Like those are one of the things I want you to understand, right? So here, the description of the process is saying half-liter cans are filled with wall or ceiling paint at a manual workstation, and then they are saying the lids are pressed with the aid of a pneumatic press, right? And then they are saying the cans are inserted manually into the press, right? And then they are saying after pressing a push button, the press cylinder is advanced to press the lid. They're saying the press cylinder is advanced to press and the lid is fitted, which means when you press a push button, this cylinder advances to press the lid here so that it's tightly secured, right? And then they're saying when the push button is released, the cylinder retracts back to its initial position, right? And then they're saying the steel cans are removed manually, right? And then the conditions, they're saying a double acting cylinder will be used, right? And then they're saying So they're saying the control of the cylinder will be will be executed indirectly by means of a push button. So now this statement is also a key statement, right? So they are saying the cylinder will be controlled indirectly, right? So now this is what they mean. So it's indirect actuation, right? So now, and then the last parameter saying in the event of a power failure, the cylinder should retract back to the original position, right? So now here, if you look at this, they're saying after, when you press the push button, the cylinder advances, right, to press the lead, and then they're saying when you release the push button, the cylinder retracts to its original position, which means you are still using the same push button that cuts the current that's going to the solenoid, right? But now, since now they said the cylinder will be actuated indirectly, right? We can't connect the push button straight to the solenoid, right? Because if you still remember, like when I explained indirect, I said indirect actuation is when you connect the push button directly to the solenoid valve so that it directly supplies current to the solenoid valve, which can actuate the cylinder, right? But in certain instances, right, for example, just give me a second, I'm just trying to look for an example like online that I can use to explain what I mean. Power station. So now I'm back now. So now I found a suitable example that you can try to use to understand, right? So now in power stations, right? So in power stations, every time, right, that they maybe cut the power for load shedding, right? So these are switches. I'm gonna just play this video, then I'm gonna explain after, right? Okay. So now the video that I just showed you, right? As you can see, they are disconnecting, they are cutting power, right, between systems, right? But like, as you saw, like how much electricity came out of those, how can I put this? Like of that connection, right? Or of that, yeah, of those connections, right? When they cut power, right? When they're trying to open them, right? You saw how much current passed through. So now, in bigger circuits, right, or in much more complicated systems, right, like let's say this solenoid requires maybe 1,000 volts, right? You can't connect a switch. You can't connect a switch directly to the solenoid, right? Because like maybe the switches like or resistors, if you still remember from electrotech, right? They have a maximum amount of voltage that they can take. So now let's say if your solenoid valve, it required 1,000 volts, right, for it to turn on, right? Mara, your switch, it's like a 24-volt switch, right? So you can't connect this directly to here. Problem being is that, like, this switch, when like 1,000 volt passes through it, it's gonna burn and it might even electrocute the person, the person who's gonna press it, right? So now we introduce the concept of a relay, right? So how a relay works, it's similar to what they do on a power station there, right? So now in a relay, they connect the push button, right, to a relay, right, and then a relay has the capabilities of sending okay, so okay, so all right, so sorry for the long. So I was still saying a relay, right? So yeah, let me start afresh. So as I was saying, or like if like for example your solenoid, right, it requires like 1,000 volts, but your push button only requires 24 volt, or 24 volt is the maximum amount of voltage it can need. You can't connect it directly to a solenoid, right? So the concept of a relay, right? A relay, it can be used like to, can I put this? It can be used to, it is used, it's basically used to provide or control circuits that require high voltage by using smaller voltages, right? So it sort of like forms a two circuit system, right? Similarly to this one here. So this is what a relay would look like inside. So it has this here, right? So what it does, as you can see, like there's two sides of the all right, yeah. So it has two sides, right? It has the relay, right, which receives a signal maybe from the smaller circuit that has 24 volt, right? And then when this relay receives the signal, it's gonna send it to to another switch, right? And then it's gonna tell that. So when, like, let's say, for example, right, I had a circuit, a switch here. I close the switch, the circuit is complete, and then current goes to the relay, right? And when the relay receives that 24 volt, right, it sends a signal to this switch, right, telling it to close, right, so that maybe let's say 1,000 volt current is supplied to the system, right, so that now you don't burn the components that are in this other part of the circuit, right. So now that's why you use a relay, right. I hope you understand, right. So if I can explain for one last time, right, connecting a push button directly to a solenoid valve, right, that requires high voltage, right, it's gonna always burn the, or it might cause safety issues, right, for you to connect it direct. So now, how you connect a relay here, right, you remove your solenoid from this side, right, and then now you get like a relay, right. This is gonna be your relay. You connect it to the push button, right, to here, right, and then now after you connect it to your push button, right, you get what you call a changeover switch, right. So a changeover switch, it's used for communication with your relay, right. So now your changeover switch looks like this, right, and then you connect it straight to power supply, and then you connect it to your solenoid, and then you connect it back to your ground, right. So if the unfortunately the version we are using of FLUIDSIM only has 24 volt, right? But in a manner of speaking, this was not supposed to be connected in the same circuit, but for the sake of this one, of the exercise, right, we'll continue it like this because our FLUIDSIM is 24 volt. So now, like as I said, so now you have the, as I showed you, you're creating two different circuits, right? So now how you get your relay to send a signal to your changeover, right, or your Q2, right? So now you define your relay as R1, right, and then you also define your changeover as R1, right? So this indicates a physical connection, right? So now how your circuit is gonna work now? You're gonna press. So now you wanna press the push button, all right? And when you press the push button, the circuit closes and then current is supplied to the relay, right? And when the relay receives that signal, it sends a signal to the changeover switch, right? Telling it to close, and then when this one closes, it's sent now to the solenoid valve, right? And then indirectly actuating the cylinder, right? So this is indirect actuation in the context of electro-pneumatics, right? So now if I simulate this, right? So now if I press this push button, as you can see, it only now closes, right, when you, so now current is sent to the relay, and then the relay sends a signal to the changeover switch telling to close, so current can be supplied to the solenoid valve, right? So that's indirect actuation, right? So now instead of us supplying current straight to the solenoid valve, right? So you would like think of indirect actuation in a manner of us, like now instead of supplying current direct to the solenoid valve, now we press the push button, right? And then push button, and then current supplies to the relay, right? And when the relay receives an electrical signal, right, it sends a signal of its own to the changeover, right, to tell it to close. And then when the changeover closes, it's gonna send, now the current is gonna be sent to the solenoid valve, right, therefore actuating the cylinder, right? So I hope now you understand how indirect actuation works, right? And also how you can describe the controller system sequence of this system, right? And then now I will stop the video, and then we'll continue exercise 3 to 6 on the next other videos, right? On another video, right? So now, thank you for tuning into this session. We'll continue our part 2 and 3 in another video, just to make sure we don't keep the video too long.